analysis, walking through the building, seeing what's there, documenting conditions, and starting to identify opportunities for improvement, things we call energy conservation measures, ECMs. So we start identifying the ECMs, and then we look at them from a technical standpoint, how much energy can we really save if we implement this strategy or that strategy. Then we turn that energy savings into energy cost, compare that to that energy cost savings to the cost it may take to implement that strategy, and look at a simple economic assessment of return on investment to see if it makes sense. And then last but not least, we do reporting. We document our findings, make recommendations to the owner, and review. So it's all written down, and then the owner can evaluate and decide how they want to proceed based on those recommendations. So let's start talking about benchmarking. Benchmarking is just knowing how much energy your building is using and where. And it really doesn't matter how you do that analysis, whether you can do it at an absolute value of energy use intensity, EUI, measured on a kBTUs per square foot per year, or maybe kWh per square foot per year basis. And that per square foot per year number is meant to normalize so that you can compare buildings of different sizes against each other. You can look at Energy Star. We're going to talk a lot more about Energy Star in the next module, but the Energy Star database to rank your building on a scale of 1 to 100 compared to other buildings. 100 being the most efficient building in the database, and 1 being a very inefficient building. 50 then would be the average building. An average performing building would have a score of 50, so you can compare. They use the CBEX data to commercial building energy conservation something escapes me right now. Or you can look at it on a cost per unit index, on dollars per square foot per year. Every building can be different. You can choose whatever benchmarking tool you want to compare your building to other building. But knowing where you are is the most important part starting any energy conservation program, because you can't know where you're going if you don't know where you are. The Energy Star database is a very good, simple tool to benchmark your building performance against similar buildings. We're going to cover a step-by-step how to find your Energy Star score in the next module. So essentially, you collect your utility bills for the past 12 months, and then you enter the total energy usage into simple one-page form, along with how big the building is, where it is, how many people are in the building, how many hours a week it's operated. If you know the cost of energy, you put that in. If you don't, it gives you some default. But you put in the simple information, and it basically spits out a number on a scale of 1 to 100 as to how your building stacks up against other similar buildings in your area. So that's benchmarking. This shows a little bit of the input and the output that you're going to get from the target finder. Again, we're going to go through a step-by-step how to on the Energy Star target finder in the next module. Then, in order to, the next step in the energy audit is the site survey and the analysis. We go to the site and investigate, see what the equipment is, what the systems are, what they're doing, how they're performing, what their status and their condition is. Are they new? Are they old? Are they operating the way you think they were intended? Are there major obvious problems? We document consider not just things that are going to save energy, but what we call facility improvement measures. These are things that the building may need to do to improve its operating performance or maybe be brought up to code that don't necessarily have a good financial payback. The best example that I can give of that has to do with outside air. Sometimes we go into buildings to do an energy audit and we find that the outside air, as dampers have been closed and screwed shut, so we're not bringing in enough outside air, enough ventilation air to meet code. Well, that's something that has to be fixed, but when we start bringing in more outside air for ventilation, then our energy is actually going to increase a little bit as we have to dehumidify and cool that air. Nothing we can do about that. We have to do it because we want people in the building to be healthy. So it's important that the strategies that we look at during an energy audit consider more than just the raw energy usage. We're not trying to just drive up temperatures or reduce outside air just to save energy. The ultimate goal is also cost saving, but it's also comfort and health for the people who occupy these buildings. The economic assessment then, as we look at how much energy these ECMs may save, we look at the real cost that the building is paying in utility costs and energy costs and energy data from the utility bills, and calculate how much in dollars these strategies may save. Compare that to the first cost to implement these strategies and calculate a simple return on investment. If we can save $100,000 a year and it only costs us $10,000 to implement a strategy, that certainly is a good ROI versus something that costs us $100,000 to implement and only saves us $10,000 a year. So we look at all the different strategies and do the economic analysis and rank them, make recommendations in our report as to what we recommend be attempted first, second, third, and fourth, with there's different schedules and timelines that may go with those.